Welcome to Lecture 1 of Cnst 6370. In this course, we will explore how quality is defined and managed in construction. We'll also look at structured approaches like Six Sigma and total quality management. Whether you're building homes, roads, or skyscrapers, quality management helps make sure your project is safe, durable, and meets client expectations. So what does quality really mean? In construction, quality is not just about looking nice or being expensive. Quality means that what we build meets or even exceeds the expectations of our clients. It performs the way it should, is safe to use, and lasts as long as expected. To understand where today's quality practices come from, let's take a look at how quality management has evolved over time. We begin in the late 13th century, during the age of craftsmanship and guilds. Back then, quality relied entirely on the skill and reputation of individual craftsmen. There were no formal standards, just personal pride and tradition. In the early 19th century, the Industrial Revolution introduced factories and mass production. For the first time, work was broken into smaller tasks and performed by many workers. This created the need for a system to ensure consistency, because now hundreds of identical items were being made on an assembly line. By the late 19th century, Frederick Taylor introduced what's called the Taylor System method for breaking down jobs into small, measurable steps. This was one of the first formal attempts to manage and control quality in a structured way. In the early 20th century, statistical tools like statistical quality control, SQC, were developed. Instead of checking every product, manufacturers used random sampling to check if the process was producing acceptable results overall. During World War II, quality became critical in military production. Engineers developed more rigorous sampling techniques and standards to ensure weapons and materials were reliable. After the war in 1946, the American Society for Quality Control, now called ASQ, was founded to promote education and research in quality methods. In the mid-20th century, Japan led the way in applying company-wide quality control. Quality wasn't just the inspector's job, it became everyone's job, from the top executive to the factory floor. This created a cultural shift that made Japanese products known for high quality. By the late 20th century, the U.S. caught up with the idea of total quality management, TQM, a philosophy where companies focus on continuous improvement and customer satisfaction. Today, in the 21st century, we are entering the era of Quality 4. This involves using digital tools like sensors, real-time data, and artificial intelligence to monitor and improve quality. It's the next generation of quality management: fast, smart, and data-driven. So, as you can see, quality management has come a long way from skilled hands in medieval workshops to smart sensors in modern factories. When we talk about quality, we can break it down into 8 specific areas. Performance: does it do what it's supposed to do? Features: does it offer additional functions or convenience? Reliability: can we count on it to work every time? Conformance: does it follow industry standards and specifications? Durability: how long does it last under normal use? Serviceability: how easy is it to fix or maintain? Aesthetics: does it look good and feel right? Perceived quality: what do users believe about it, even if they can't measure it? Many experts called quality gurus shaped how we think about quality today. For example, Deming taught us to use data and think systematically. Duran emphasized planning and continual improvement. Crosby believed that doing things right the first time saves money. Ishikawa gave us teamwork tools like fishbone diagrams. Each guru brought a unique angle, but they all stressed prevention and long-term thinking. No two products or construction projects are exactly alike. Differences in materials, machine settings, workers' skill levels, or even the weather cause variation. The goal of quality management is to reduce this variability so our work is consistent and dependable. Quality management is a structured way of making sure that every part of the construction process from design to delivery works efficiently and meets requirements. We don't just hope things go right, we use tools and checks to control how things are done, using data to improve over time. TQM means everyone owns quality. It's not just the inspector's job or the engineer's job, it's everyone's job. From the office to the job site, people work together to improve processes and products. The focus is on customer satisfaction and continuous improvement, small steps, taken every day. Six Sigma was created by Motorola. It's a way to use data and statistics to find and eliminate errors. The name Six Sigma means your process is so good that only 3.4 defects happen in 1 million products. That's incredibly precise, and it pushes teams to strive for near perfection. Here we give a short explanation about where the name Six Sigma come from. Sigma is a statistical term used to describe the variation. 1 sigma means 1 standard deviation. In this slide, the x-axis represents all possible quality values. The green curve represents the likelihood of those values. The values between the two limits represents the good quality. The values outside the limits represent bad quality. The specification limit can be understood as the tolerance level of the quality. If we set the specification limits to be different multiplication of sigma, the expected number of bad quality products can be found in the right column of the table. As can be seen that, if we set the specification limit to be 6 sigma, there will be 0.002 failures per million production. But where does the number 3.4 come from? According to the Motorola Six Sigma developers, it is hard to measure the target value at a specific point. Instead, there will be a plus and minus 1.5 sigma range for the target value. The target value here represents the perfect quality value. In this case, the failure rate will be between 4 sigma and 5 sigma in the table, which is around 3.4 per million. So that's where the 3.4 number comes from. In summary, the idea of Six Sigma is to reduce quality variability, so that most products will be within the specification limits. Lean construction borrows ideas from car manufacturing. It focuses on eliminating waste like waiting, overordering, or rework and maximizing value. Everyone from designers to workers coordinates closely so the project runs smoothly. It's about better planning and fewer surprises. Let's compare the three. TQM builds a culture where quality is everyone's job. Six Sigma gives us tools to reduce mistakes with data. Lean construction focuses on making work flow better and cutting waste. These aren't separate, they actually support each other. Many firms combine them into Lean Six Sigma, built on TQM principles. To sum up, quality isn't just about checking things at the end. It's about building smart, working together, and using data to avoid mistakes. Whether it's Six Sigma, Lean, or TQM, the goal is the same: better results, happier clients, and safer projects. Thanks for your attention, and I look forward to our next session.